Hi, good morning. Today we are going to see about combinational circuits. In that we are going to see about encoder and decoder. In previous video we have discussed about half adder, full adder, half subtractor and full subtractor. Now we are going to see about encoder and decoder. Binary code of n digits is can be used to store 2 power n bits distinct element of coded information. This is what encoders and decoders are used for. Encoders convert 2 power n input lines of input into a code of n bit, and decoder decode the n input into a 2 power n lines. Encoder is mainly used in switching circuits, where we are using continuously changing the input. There we can use a select line so that we can select which work to be done first. Based on the priority we can select that process. Here there we are using encoder and decoder. What is decode? First of all, let's see about encoder. Encoder is a combinational circuit that converts binary information into a form of 2 power n input lines and n output lines, which represent a n bit code of the input. For simple encoder, it is assumed that only one input line is active at a time, based on that we can generate output lines. Decoder is also a combination circuit that converts binary information from encoded input into a 2 power n unique output lines. Decoder has n inputs and 2 power n outputs. Decoder select one of 2 power n input by decoding the binary value of n inputs. The decoder generate all of the minterms of n input variables. Exactly one output will be active for each combination of the inputs. This is a block diagram for decoder. We are giving two input, and we are getting output as four outputs. We are giving two variable as input, and 2 power n equal to 4. We are getting four output lines. This is the truth table for encoder. In this truth table for decoder, we are getting two input lines like A1 and A0, and for two variables we are using a possible combinations, four possible combinations, so that we can get the data of D0, D1, D2, and D3. This is the circuit diagram for decoder. We are giving a input. Based on that input, we can select which input to be given as output by using by based on that we are designing the circuit diagram. This is a 3 to 8 encoder. This is 3 to 8 decoder. We are getting three inputs and having an output of 8 from possible combinations of for we are using three variables, so we can get a 8 possible combination. Based on that we are getting output as y0, y1, y2, y3, y4, y5, y6 and y7. These are the combinations of output we are getting. Basically, encoder is used in a transmitter side and a decoder is used at the receiver side. Based on the data we are receiving, we can decode that signal. That is why we are using a decoder. We are having an A and B inputs and enabling lines will be there. Based on that, we are getting output as Z0, Z1, Z2, Z3. Why encoders? Encoder has 2 power n inputs and n output. It's just an opposite of decoder. Output the binary value of the selected input. It performs the inverse operation of a decoder. We are having a 2 power n input and n output lines in encoder. This is a basic block diagram for encoder. We are having a four possible combinations are that means y0, y1, y2, y3. We are getting an output of two input that we are given to the decoder A and B. Here we are using. It is just an opposite of a decoder. It is used in a transmitter side. Encoder is used in transmitter side, and decoder is used in the receiver side. This is an 4 cross 2 line encoder. We are having given 4 inputs and we are getting output as two variables. We are also having a priority encoder. If more than one input is active, higher order input has a priority over the lower order input. Higher value is encoded on the output. A valid indicator D is included to indicate whether or not the output is valid or not. Output is valid when no inputs are active. Then D equal to 0. Output is 1 is valid when at least one input is active. That time D equal to, we are getting D equal to 1. This is the block diagram for priority encoders. We are having four, eight possible combinations, eight input lines. That means Y0 to Y7. We are getting an output of four, three input of MSB and one bit as a valid bit. Once using an n output decoder to realize the logic circuit for function with n minterms. Each minterm of a function can be mapped to an output of the decoder for each row in the truth table for the function where the output is 1. Sum the corresponding output of the decoder. Sum is the corresponding output of decoder. This is for each minterm and the expansion of logic function or corresponding to the output of the decoder. Thank you.